Okay, so let me pull up the notes from last year. I want to make sure I'm giving you guys the same information. But yeah, if you guys do end up retaking the quizzes or tests, just know that they're the same like problems in the issue give you, but it's different numbers. So if you made a mistake on the first time, then just learn from it and then just retake it. So that was chapter 2, 2-4. Um, okay, imaginary numbers. So imaginary unit I is equal to square root of -1, but you guys should also know the other important ones. So I squared is -1. I cubed is -1. Sorry, negative I. Sorry, because I squared is -1, so that means you're left with one I, so it's negative I. I to the fourth is +1. So every 4 is +1, every 2 is -1, and every 3 is negative I. Okay. So it says you can add subtract. This is pretty much the standard form of it. A plus or minus bi. The imaginary is the second part. The real is the first part. And this one says perform the operation, write the result in standard form. So in this case, all you're doing is just combining like terms. So 11 minus 2i. Since they're only adding and there's no term in front of the parentheses, or there's no distribution. So it's just plus. Or you can write it as -3 plus 6i. And then all you have to do is just combine like terms. 11 minus 3 gives me 8. And then -2i plus 6i is +4i. So standard form states you must have the real first and then the imaginary second. For the next problem, you have a negative, so you have to distribute the imaginary -1. So 7 plus 3i -3 minus 6i. And then just combine like terms. So you get +4, -3i. Pretty easy enough, not too bad. Okay, for number 11, so there's two ways to do this. Honestly, the easiest part is knowing that anytime you square a square root, they cancel and you get just what's inside the radical. So this is just a -75. Now, if you want to do this the long way, which is possible because it's not always going to be a square, this is how you do it. So we're gonna break apart the base of the inside term. So this is -1 times 75. When you break it apart, square root -1 times square root 75, right? Square. Um, then you should know that convert radical to exponential. -1 square root. Sorry, the square root of -1 is just -1 to the power of 1/2 times 75 to the power of 1/2 squared. Now the power of exponents to exponents means you're going to take this exponent and multiply it to each of the exponents inside the base. So you'll have -1, 1/2 times 2 times 75, 1/2 times 2, and then just multiply. 1/2 times 1 is just 1. And then 1/2 times 1 times 2 is just also 1. So then you can just simplify it as -1 times 75, which gives you -75. So this is honestly the long way of converting radicals to exponential. So the exponent to the exponent rule. Now, the only reason why I could do this the shortcut way is because you both have radicals, a radical to the power of 2. So just got to be careful. 32, distributive property, negative 18i, my positive 3i squared. 3i squared is negative 1. So negative 3, and then rewrite it in standard form, negative 3 minus 18i. Does anyone have any questions? Okay. Perform the operation, write the result in standard form. So just do the box method or the distributive method. 1 minus 2i times 1 minus 2i minus 1 plus 2i, 1 plus 2i. Because remember, the exponent tells you that there's two of them. So now do the distributive property, or you could do the box method. Since they're both binomials, you could just do distributive. So 1 minus 2i minus 2i plus 4i squared minus 1 plus 2i plus 2i plus 4i squared. When you do distributive property, combine like terms, simplify. Kind of have to do a lot of parentheses. So here you'll have 1 minus 4i minus 4 minus 1 plus 4i minus 4. So combine like terms, negative 3 minus 4i minus negative 3 plus 4i. Distribute the negative. Negative 3 minus 4i plus 3 minus 4i. Combine like terms, negative 3, positive 3 cancels. You're left with negative I as your final solution. So do be careful. You can get confused with the distributive property. So make sure you take your time. Do not rush through it. If you're going to be in your head, you're going to have to be very, very careful, especially when doing the homework. Because on the test or on the quiz, or sorry, in this case, it's going to be the test. Make sure you double check your work. Okay. Write the complex conjugate of the complex number, then multiply the number by the complex conjugate. So pretty much, if it's a plus b, you're gonna multiply it by a minus b, and it's a difference of the squares. So a squared minus b squared. So the conjugate for negative 3 plus the square root of 2i would be, when you multiply the conjugate, negative 3 minus square root of 2i. Now do be careful. The I is outside the radical. Do not make the mistake of putting it inside the radical because that would be incorrect. Because we're multiplying by the conjugate, we're going to take the shortcut where a is equal to negative 3, b is equal to the square root of 2i. As a matter of fact, I'm putting in the front because if I put it in the back, it's kind of confusing, but the I is technically is supposed to go in the back, but in this case, I'm putting it in the front to make my life easier. So since we're multiplying the conjugate, a squared minus b squared is a shortcut. So we're just plugging it in. Negative 3 squared minus I square root of 2 squared. Positive 9 minus I times sorry, I squared times 2. Because since we're squaring this is left with 2, but I squared is just I squared. But I squared is -1. 9 minus -1 times -2 is -2. When you subtract the negative, you're adding them. So positive 11 would be my answer. Yep. The next one, multiply the conjugate. 1 minus square root of -8. A is +1. And B is square root of -8. A squared minus B squared. We're going to use that proportion. 1 squared. Oops. Square root of -8 squared. I'm just going to take the shortcut. If I square a radical, I'm just left with -8. Subtracting by a negative becomes positive. What?
What's this for exactly? Something.
To write complex conjugate of the complex number.
What is that?
You need this for the next part.
Oh, okay. Because I'm like just thinking, it feels like we're just adding the complex conjugate. So I just question why we're gonna have that.
So for the next part, write the quotient in standard form. Much like fractions where you're not allowed to have 0 in the denominator,
Yeah.
and you're not allowed to have radicals in the denominator, it applies also with complex equations. You're not allowed to have imaginary numbers, or sorry, imaginary portion in a fraction, in a rational. So you have to write the complex conjugate of it. So that's the whole point of it. So you can't have zeros on the bottom. You can't have radicals on the bottom. You can't have imaginary parts in a radical either. So in order to get rid of the imaginary in the denominator, I have to multiply it by the conjugate. But since I'm multiplying by the denominator, I have to multiply by the numerator as well. Does that make sense?
Yeah.
So honestly, the last part was just practice for this part.
Okay. I was like confused why we're gonna need that, because it feels like, why would you ever just add an additional number to make your concept more confusing?
It was just practice on
Okay, makes sense.
yeah. So now 3 distributing. 3 plus 3, all right. So the numerator is always the easiest part. The denominator is the part that's kind of tricky. But since this is a difference of the squares, it's the same thing. A is equal to 1, B is equal to I. So A squared minus B squared. 1 squared minus I squared. So 1 squared minus I squared. And we know that I squared is equal to, 1 minus -1, which gives me 2.
That doesn't really matter in this case.
What?
I was saying you're missing the negative on I technically, but I mean, I don't think that's
What I?
the 1 minus the I, so, or no, we would let them, wait. No.
I squared is -1.
Yeah, no, I was just saying,
Okay.
it doesn't matter, I was saying the negative this thing, but we're doing quadrat or squares, so
Yeah.
it doesn't matter.
Exactly. So to write this in completely standard form, you kind of have to break it apart. So this is technically the correct, most accurate answer. 3 halves plus 3i divided by 2. So for this one, you're gonna have to simplify first.
You not plug in for A4 and B4 instead?
Nope,
No, that doesn't work.
nope, doesn't work. So when you simplify the denominator, you'll get -5 plus 12i. So then when you simplify the conjugate, you're going to multiply it by -5 minus 12i, and then -5 minus 12i. It ends up being a lot more complicated if the numerator also has an I, so you just have to be very, very careful. But for the denominator, a is equal to -5, b is equal to 12i, so a squared minus b squared. So -5 squared minus 12i squared, positive 25 minus 144i squared, which is equal to 25 plus 144, which is 169. Double check my math because I'm doing it in my head. For the numerator, simplify. Oops. I squared is -1. Positive 60. But I want you to write in standard form.
I really want to know, really want to just a more convoluted way of simplifying it, you can simplify it even more technically. I mean,
So technically, this is the most accurate answer.
no, you could I think you could simplify more. We have that for this, and but yeah, because you could square
There's
it,
60 over 169.
you could square it. Because 169 squared is 13,
Yeah.
and 25 is, the only problem would be I,
Oh, yeah, no, you can't because of the I.
yeah, I was.
I think 60 over 169 can be simplified, no? No, it can't.
Like you can't compare the top and bottom, just simplify.
No, yeah, you can't. Yeah, you can reduce it.
You also know that it's not for, you know, it's like even if something. I mean, you could, I think it actually make the equation more easy.
Yeah, you can't square both top and bottom to simplify, so you have to be careful.
If we just put 60 minus 25 I over 169 and not the final, where we put minus top and bottom or something. You can find anything.
Mm, Well, since I'm telling you, yeah.
Oh, no, then. This is what
Because technically 60 over 169 minus 25i over 169 is technically the most accurate answer. If you leave it at 60 over 25i over 169, you're just being lazy. Don't want to finish it. So you just have to pick it apart. All right. Any questions on this problem? You guys good? It's just tedious. It's just a lot. All right. These are the ones that are honestly probably the most annoying is when you have two two rationals. 2 minus I, 2 minus I, but then this one's going to be 2 plus I, 2 plus I.
Wait, oh, wow.
So for the numerator, 4i minus 2i squared. So double check my work. So the denominator, a is equal to 2, sorry. A is equal to 2, B is equal to I. So if I plug it in, so for that one, you'll get 5. What?
Oh no, that's the top one. I was looking at the bottom. I was thinking you were multiplying the percent, but with that number. I don't get the wrong part of the equation.
Plus 10 my plus 5i. Now, since this is honestly the same as this, I'm just gonna put 5 on the bottom. It's the same thing, so I'm not gonna write it twice since I already
If you
did
get
it for the
wrong, you already have a problem.
what?
I said if you got the other side wrong, then you have a problem.
Yeah, but double check my work because it looks pretty accurate.
Right.
All right, so then let's make it look nicer. So we have 4i minus 2i squared divided by 5 plus 10 plus 5i divided by 5. We want to simplify the left numerator. Remember, I squared is -1. Did you guys learn imaginary numbers in Math 3?
Yeah, I think we're going to wait for that.
Okay, that's good.
Honestly,
Huh?
math too. I think we learned them both.
I don't think in Math 2 I teach my Math 2, so I don't think we get that far.
I don't know. I know we've learned that. But yeah, we do. I feel like second semester we got to. I think we did know learned it and we're good.
All right. So they combine the numerator. So remember for the rule of fractions, the denominator stays the same. 2 plus 10 plus 4i plus 5i. It did. 2 plus 10 is 12. 4 plus 5 is 9i. So 12 over 5 plus 9 divided by 5.
Two over 5 plus 1 and 4i over 5. Making a base number.
What?
I said I should write it like a 2 and 2 over 5 plus.
Oh
one
my
and
god.
4i.
No, dude, it's honestly the worst.
That was horrible.
Yeah, those are terrible numbers. These are nice, good looking numbers. Don't.
They got used to this since like middle school or earlier.
Okay, we're almost done. The last part. Simplifying the complex number and write it in standard form. So all you have to do is just same thing as the previous one. So in this case, we have -1 times 48 to the power of 3. Okay. How did I do it put together? God. Okay, how good are you guys simplifying radicals? Okay, would you simplify the square root 48? So remember, this is negative. So 48 is 16 times 3, and this is 4 times 4, right? Okay, because you are going to need to know how to do this part. So this is something you learned in Math 1, and for some reason, this is the part that students always struggle with. So square root of 48 is 4 times 4 times 3. And then obviously, well, technically, you can just leave it as 16 times 3 because the square root of 16 is 4. And honestly, it just depends on how you do it. Like you could do it the long way, but I know in Math 3, you learn how to find the perfect squares inside inside the radicals. So that way you know that, okay, if there's a number there that can be square rooted, you want to leave it alone because you can actually square root that number. And then you're just left with a prime, which in this case is 3. But honestly, it just depends on how you learned in math 3, or the long way. Because the way I teach it in math 1, we do it the long way. Because it yeah, it honestly just yeah, the factor trees and everything. And honestly, it just depends. Like it takes a while for some students to like see like the perfect squares in the common base. So
So we
yeah.
have to do like, we have two twos.
Yes, exactly. Yes. That's the way I teach math 1 and even some math 2 because it's
I mean,
yeah.
it's a good way to start looking at it.
Yeah, exactly. It's honestly the best way to start it, and then eventually when you get to higher level math, you gotta look at it. Yes, exactly. Yes. And for some students, it takes a while. And then, yeah, but definitely you gotta look at the patterns for it. So that's where I just write it as 16 times 3 because I know I can take the square root of 16 and 3 is already a prime number and I can't take the square root of that.
Or lower math grades scared me because some things I've seen are still using like calculators for basic arithmetic, and I'm
Yeah.
like, bro, that's gonna make you struggle later. You gotta start seeing the patterns.
Yeah, no, and I agree, and I agree. And then even though yes, you can use a calculator, you gotta be able to look at the patterns. Is that's honestly the best way to be able to be good at math is just looking at the patterns for it. Okay, the square root of -1 is just I. And then all we're gonna do is just take the 3 and we're gonna give it to each of the exponents. So how are we gonna write that? I times to the power of 3 times 4 to the power of 3, and then radical 3 to the power of 3. So I cubed is negative I, negative, oh, sorry, my bad. Negative I, you're right. Yeah, because I squared is -1, and then you have a leftover I, right? So negative I, and then 4 times 3 is 4 to the power of 3 is 64. And then radical 3 to the power of 3 is
You can just do three radical three, can't you?
what do you mean 3 radical 3?
You have two extra threes.
Yes. So here's how you can do it. So I probably should have done it in the very beginning. Converting this radical 3
Oh, so
1/2. Because then this would be 3 times 3/2. 3 to the power of 3/2.
are you gonna leave it like that?
No, you'll see. So it's honestly just weird, but like the algebraically when you do it. So well, if you get to the same answer, that's perfectly fine. So negative I times 64. Now 3 to the power of 3/2. I'm gonna write it as 3 to the power of 3 to the power of 1/2.
Oh, you're saying if you did this earlier, this would work better?
What?
Actually, 150 cents works better.
Which part?
Like this in general, how it's. I don't know. See how it's like.
If you get to the right answer at the very end, that's fine. So the square root of 27, right? Right.
That's what I just. That's what I was saying. We have square root of three of square root of 3 to the power of 3. I was just 3 square root 3. It's just like the easiest way to preserve it.
Yeah.
I thought there was like some other thing was going on here. Then it got so I was like, wait,
Yeah.
done that all the way back there.
Yeah, honestly, we could have just done it back there, and I don't know. It just honestly depends on how you look at it, because square root 3 converts to 3.5, and then you're multiplying by the exponent, so you get 3/2. But technically, you could break 3 to the power of 3/2 apart to get 3 to the power of 3 times 1/2. Simplify 3 to the power of 3, which gives you 27. Then take the radical of it, find the perfect square, which in this case is 9, and that becomes 3 radical 3 and then multiply it. But you technically didn't have to do that because you could have also done this. This to the power of 3 is just 20, sorry, 3 to the power of 3, which gives you 27, and then that simplifies to 9 times 3, which is 3 radical 3, and you'll still get to the right answer. And honestly, just the way you look at it. I would have done this just because this like shows your work. I mean, honestly, you get to the right answer either way. So
2 words.
I probably shouldn't have done this. I probably should have just done this part right here.
2 words gave them logic. I literally just multiplied. Oh, I didn't even, your second option is less than more work than even I was gonna show. I was just gonna go straight to 3/3 because we talked about if you can see the shortcut, then squaring 3 in the radical is immediately just 3. So I was just gonna take a 3 out and remove 2 squares.
Oh, yeah. Yeah, you can do that too as well. But this is the algebraically of showing everything. But honestly, I should have just went to this part right here. Because you're multiplying by 3 and then you're cubing it and then you're square rooting it and then that's how you get through 3. But I like this way too. Because technically this is kind of how the book actually has you do it. So all right, the last part's really easy.
Oh, it is?
Yeah, because remember, on the plane of this, your x-axis is the real, your y is the imaginary.
Oh.
So if I wanted to graph -7 plus 2i, -1, -2, -3, -4, -5, -6, -7, 1, 2, it'd be right here. -7 plus 2i.
No idea then. Oh, I thought this was gonna be so much more.
Nope, that's it.
Okay. That's the one.
The only one that might be hard are these ones where you're simplifying complex numbers and write it in standard form. And honestly, how you write it, just write it out the way you would write it, and then just make sure it follows through perfectly to the very end. So just have to be very, very careful.
This. Okay. Oh, do it. Or you did it. Yeah, and that's the other one.